Hi everyone. So in the last class we discussed about different networks and how they are divided into different classes: Class A, Class B, Class C, Class D, and Class E, and how each network gets its number of IPs or number of hosts. And in this class we'll discuss about casting, unicast, and the broadcast. So let's start with the unicast. Unicast is nothing but when you send a data packet from one host to a different host. It's a one-to-one. You're sending a packet from one host to the other host. Then it's called a unicast. Uh, for example, uh, you're sending a data packet from network. This is a network, and this is a host to a different host in a different network. Unicast. Suppose let's call it a network from class A. Let's take it as 22.0.0.2 to we are sending to a different network, maybe a different network in class A 30.0.0.0, and let's call the host as 22.1.2.3 for example, and this one 30.1.2.2, and you're sending a packet from this host in network 22.2.0.0.2, this host 30.1.2.2 in this network 30.0.0.0. Then it's a unicast. So you're sending your data from one network, one host. It's a source address, it's a destination address. Your source address is 22.1.2.3, and your destination address is 30.1.2.2. So you're sending a packet from source address to the destination address. It's a 1 to 1. Then it's called unicast. And let me tell you network, how you represent a network. Suppose here I told this is the network here 20.0.0.0, and here I told you're sending it a packet to a different network 30.0.0.0. So it's nothing but as we discussed in the last class, your IP is represented by a network ID and a host ID, and you represent your network by your network ID and all zeros in your host ID. So here, as it is a class A network, your network ID is your first 8 bits, and your host ID is next 3. So you have your network ID and 000 for class A. Suppose if it's class B, then you have your network ID in your first 2 and your host ID 0 and 0, class B. Suppose if it's class C, then you have your network ID in first 3 and you have 0 here. This is class C. So you have all your zeros in the host ID part to represent a network. So here it's 22.0.0 and here 30.0.0. So your network is represented by network ID and zeros in the host ID part. That's how your net represent your network. And let's talk about broadcasting now. So in the broadcast. So in the broadcasting you have two. First one is limited broadcasting, and second one is direct broadcasting. So let's discuss on what is limited broadcasting. Suppose if you are sending a packet from one host in a network to all other hosts in the same network, then it's called limited broadcasting. For example, you have suppose take a class A network 22.1.2.3. uh, Sorry, take a class A network. Network is 22.0.0.0. So your network is 22.0.0 and your host, suppose it's 22.1.2.3, and you want to send a packet to all the other hosts. So since it is a class A network, how many hosts you have? It's 2 power 24, which is approximately equal to 16 million hosts. So you want to send a packet to 16 million hosts in the same network, then it's limited broadcasting. So you send your data with your source address, which is 22.1.2.3, to uh, all the hosts, which is limited broadcast. So you represent this by 255.255.255.255. So when you send a data packet from a host with your destination address as 255.255.255.255, then it sends the packet to all the other hosts in the same network. This is called limited broadcasting. The advantage here is you can send your data packet using a unicast to all other data packets, but it requires suppose here you have 16 million hosts. So if you use a unicast way, you have to send your data packet to all the 16 million hosts. So you should have 16 million data packets, and you have to send it from your source address to each of the destination hosts. So 16 million data packets, source address, and 16 million destination addresses. So it's not uh, good on the software or the hardware part. So we prefer the limited broadcasting address. So unicast you can send, but the preferred method is limited broadcasting address, where you send your data packet to all the other hosts, to all the 16 million hosts, with a single data packet with a destination address of 255.255.255.255. This is called the limited broadcasting. And let's discuss on what is direct broadcasting. So direct broadcasting. So direct broadcasting is nothing but when you want to send a data packet from a host in one network to all the other hosts in a different network. Suppose you have your network 22.0.0.0, and your host, suppose it's 22.1.2.3, and your next network, let's take a class A network 30.0.0.0, and since it's a class A network, again it has 24 hosts or IPs, and you want to send to all of them. So here you send it using direct broadcast address. So here you're sending your data, your source address, you keep it as 22.1.2.3, and your destination address is your network ID followed by all 255s. So just as in the limited broadcast you have all 255s in your destination address, here you have all 255s in your host ID, and your network ID remains same. So when you want to send a data packet from one host in a different network to all the hosts in a one host in one network to all the hosts in a different network, you just need to send to a destination with a network ID with all 255s in the host ID. So your destination direct broadcast address is your network ID, your host ID, your network ID remains same, and your host ID has all ones. All ones. Same way in the limited broadcasting address, it's all ones. All ones. It's 255.255.255.255, but here it's network ID followed by 255.255. It depends on what class it is. What class? So this is your network ID and host ID, your direct broadcast address, and limited broadcast address. As I told you in the previous class, for each class you have uh, for each class, and suppose in class A network, for each network you have 2 port 24 IPs, but I told you like two IPs are reserved for a specific purpose. So in class A, suppose you have 2 power 24 IPs, and two IPs are reserved for a purpose. So for the first IP is reserved for network ID, to represent a network, to represent a network, which is network ID followed by all zeros. This is just to represent the network. And the second IP is reserved for your direct broadcast address, which is network ID followed by all the ones. So in every network, like each network has its own number of IPs, and two IPs are reserved, one to represent the network, which is network ID followed by all the zeros, and the second one is for direct broadcast address, which is network ID followed by all the ones. Here I'll give you example of different classes, and I'll discuss about the network ID part, direct broadcast address, and the limited broadcast address. So let's explain you guys with the example in a table. So you know, right, for the class A, it starts, your first 8 bits starts with that's in the binary. In the hexadecimal, it starts from 121 to 126. Class B, it's 128 to 191. And class C, it's 192 to 223. Suppose you have your IP here. IP, suppose one, let's take simple example, 1.2.3.4, and you know this is a class A network. So what would be the network ID for this one? So network ID for this one is, since it's a class A, as it's with the first in the hexadecimal, the first one is between 1 to 126, it's a class A. So your first network ID is 1 and followed by all the zeros. This is network. So 1.2.3.4 belongs to 1.0.0.0 network. And what is your direct broadcast address? So as I told, direct broadcast address is your network ID followed by all ones, which is 255, 255, 255. And what is limited broadcast address for this? It's always 255.255.255.255, right? Let's take one more example. Let's take one more class A example. Suppose 20.1.2.3. Since 20 lies between 1 to 126, it's a class A. Again, your network, you represent this network by network ID followed by all the zeros. So 20.1.2.3 belongs to the network 20.0.0.0, and your direct broadcast address is 20.0.0.0. 255 dot 255 dot 255, and your limited broadcast address is again 255 dot 255 dot 255 dot 255. Let's take an example from now sub class B. Let's take 135 dot maybe 2 dot 3 dot 1. Since it's a class B network, you have and 135 lies between 128 to 191. Your network ID is 135, the first 16 bits, dot 2, followed by two zeros. So 135.2.3.1 belongs to the network 135.2.0.0, and your direct broadcast address is 135.2.255.255. Your limited broadcast address is same. Let's take one more example, maybe 190.10.2.1. Since 190 lies between 128 to 121, your network is 190.10.0.0, and your direct broadcast address is 190.10.255.255, and your limited broadcast address is same. Let's take one more in class B. I just want to make a thing clear here. Maybe 190.0.2.1. So here the first two represents your network ID, right? So 190 dot is 0, 0 dot 0 dot 0. Since your first two 8 bits are 190.0, and here again 190.0.255.255, and this remains same. Now let's take an example from class C, 210.100.2.5, and since first 24 bits represent class C, you have your network as 210.100.2, which is your network ID, followed by 0. This represents the network, and direct broadcast address is 210.100.2.255, and limited broadcast address is same. And one more example, suppose 220.200.100.1, the same thing. Your this network is this. The first three 24 bits are 220 to 200, and D.B.A is 220.200.100.255, and this remains same. Let's take for example 250.1.2.3. Since 250 is from class A, and class A doesn't have a network ID and a host ID, as we discussed in the last class, it doesn't have a network ID, doesn't have D.B.A or limited broadcast address. Let's take an example, maybe 300.1.2.3. 300.1.2.3 doesn't represent the IP, because your IP, all the IP ends with 255. So 300 is greater than 255. It doesn't represent a it doesn't represent a IP address. So this is not valid. This IP is not valid. Not valid. Not valid. Yeah, I hope it's clear on casting, unicast, broadcast, limited broadcasting, and the direct broadcasting, how a network ID and the host ID represents a network, how it represents a limited broadcast, and how it represents a direct broadcast. And in the next class, we'll start with the subnetting.